Hello everyone, welcome at my talk. I'm glad for being here with you all. My name is Rodolfo Concurdi. My talk is about fuzzing, finding your own bugs in 0 days. A little about me. I'm a penetration tester, instructor of IT, consultant of information security throughout 10 years. I'm a certified ethical hacker by the Council. I'm author of 2 magazines, one Hacking 9 magazine about Stack Overflow, and the Pen Test magazine about Cover Channel, and this is my LinkedIn profile. Our agenda about fuzzing. We will see types of targets, types of attacks, types of fuzzers, buffer overflow, and we have a POC. Types of targets might be protocol, application, and file format. Protocol might be FTP, POP3, and SMTP, Telnet, anyone. Application, any input of any application. File format, any file format, MP3, MP3U, MP4 for the test the software's reader. Types of attacks. Fuzzers would try a combination of attacks on numbers, chars, metadata, pure binary sequences. Insanity for the target, one list with sequence of dangerous string. Example, -999, Ali1, alert1, and etc. Again, insanity for the target, one list with sequence of dangerous string. Buffer overflow. Buffer overflow is an anomaly where a program, while writing data to a buffer, overruns the buffer's boundaries and overwrites adjacent memory locations. Might be RIP-based and stack-based. RIP-based, placed in the memory, which allocates a lot amount of data and dynamically. Stack-based, allocate a limited or fixed size of data, such as data from local variables or functions. Here we have a buffer overflow code example. In this code, we have a variable buffer with size 5 bytes. To overflow, we need more than 5 bytes. What's the problem with this code? The problem is that this code don't verify what's happening with this application if user insert more than 5 bytes. So if user insert more than 5 bytes, will occur the overflow. The application will crash. Here we have an image of overflow. In left image, we have a variable flow with 11 A's. In right image, we have variable flow with 150 A's. This problem is that a lot amount of A's overflow this stack, occur stack overflow. Overflow the memory. Now we have a POC. Discover input format to realize the fuzz. Example of the protocol POP3. Each protocol has your own specification. In this case, the protocol POP3 has specification document RFC 1081. Document RFC 1081 is a document of the specification of protocol POP3. This document tells that the protocol will send for the user a command user and command pass. Again, this protocol will send for the user a command user and command pass. And here we have a Python script for the fuzz. In this script for the fuzzing, the attacker will send into a user, and the pass command will send against this target in port 110. Will send against this target in port 110 a lot amount of character A. Again, this script will send a lot amount of character A against the target in port 110 into command user and command pass. Let's see the POC now, the movie POC. Let's see the movie POC. Let's run the nmap command against the target. And we see the port 110 as open, because it's running port 110 a protocol POP3. Port 110 as open. Now let's see our fuzzing script. You send variable buffer character A. You send a lot amount of character A in against the target in port 110 into command user, command pass. Is the protocol POP3 that is sent for the user a command user, command pass, but the attacker is sending a lot amount of character A's into a command user, command pass, with goal of cause a crash in protocol. Let's run in the fuzzing script. As we can see, we'll send a lot amount of bytes of character A. And the port 110 is down. Protocol POP3 is down. Let's continue with our slides. Now we will see another POC. Here has a link for download of vulnerable software, and we should open this vulnerable software in Vulnerable Debugger. Let's see another POC movie. Let's see our exploit code. We have a variable buff size with 50 downstream size, and the variable buffer with a lot amount of characters. We will send this a lot amount of characters against the target. We load this a lot amount of character, we load in this target. For generate this a lot amount of character, we will use a tool, pattern create. Pattern create is a tool of Metasploit framework. We will type pattern create -L of length space 50 downstream. And let's copy and paste this a lot amount of character in our exploit code. And we paste a lot amount of character in exploit code. Now let's compile our exploit code. Let's compile with per and the name of the exploit code. we have a compiled exploit code. Now let's copy the compiled exploit code in another VM. Now let's open the immunity debugger. Open our vulnerable software. Open our vulnerable software. And attach our vulnerable software in immunity debugger. Attach our vulnerable software in immunity debugger. This software is paused. Let's run the software. Now let's load our compiled exploit code in vulnerable software. Let's load our compiled exploit code in our vulnerable software. We have a EIP register address, register ISP with a lot amount of character. Register EIP will indicate an address of the process, next address of the process will execute. Again, the register EIP will indicate a next address that the processor will execute. In register ISP, we will put our shell code. Here in register ISP, we have a lot amount of character. In place of this character, we will put our shell code to make a reverse shell. For this, we needed to make a jump from register EIP to register ISP. We needed to make a jump from register EIP to register ISP. In ISP, we will put our shell code to make a reverse shell. Now let's use a tool, pattern offset. Pattern offset is another tool of Metasploit framework. The tool is used for finding the offset of the address. We type pattern offset -L, the length, 50,000 of the size, -key of carry, and the address of the EIP. Address of the EIP. And we found offset 35,056. Now let's write this offset in our exploit code. Let's write the offset 35,056 in variable junk. What this means? The variable junk will fill of character A for the x41. X41 means character A will fill with character A till offset 35,056. This offset 35,056 is offset of register EIP. This offset is an offset of register EIP. We will fill with x41, that means character A. We will fill with character A up offset of register EIP. In register EIP, we will overwrite with instruction jump ISP. Again, in register EIP, we will overwrite with address of jump ISP because we needed to make a jump from EIP to ISP. We needed to make a jump from EIP to ISP because in ISP we will put our shell code for making reverse shell. For this, we need to find a module with instruction jump ISP. We need to find a module without security mechanisms. We need to find a module with safe as E8 as false, ASLR as false, NX-compat as false, and the OSDLL rebate as true. We need to find a module without security mechanisms. We found a module msvols.dll. We found a module msvols.dll. Now we will use a tool NASM shell. Tool NASM shell will help us to find a jump ISP, a expression jump ISP. And we found FFE4. FFE4 means jump ISP. FFE4 means jump ISP. And now we type exclamation mona find -s XFFXE4, that means jump ISP, -m of module in module msvols.dll. We want to find XFFXE4. We want to find a jump ISP because XFFXE4 means jump ISP. We want to find a jump ISP inside of a module msvols. We want to find a jump ISP inside the module msvols. And we found the address. This address below, this address means jump ISP. This address means jump ISP. And we write this address here in variable EIP. This address X5B, X13, XBA, X01, this address indicates a jump ISP. This address means jump ISP. Because the address will make a jump ISP. In ISP, we will put our shell code. Here below we have in loops X43. X43 means sys. We will write some sys in register ISP for we see what's happening. Let's compile our exploit code. And then let's copy our compiled exploit code in another VM. Let's copy our compiled exploit code in another VM. Let's run the vulnerable software. And let's load our compiled exploit code in our vulnerable software. And we have a jump ISP In ISP, a lot amount of sys. In place of some lot amount of sys, we will put our shell code. Again, in place of this a lot amount of sys, we will put our shell code. Let's open another exploit code. This exploit code already have a shell code. We will erase this shell code for putting a new shell code. For generate our shell code, we will use a MSVinum. MSVinum is a tool that generates our shell code. We type MSVinum-p of payload, shell reverse TCP, L host, L port, -f of file per, -e of encode shikata-ganai, -b of bad char. And we generate our new shell code. Let's erase our old shell code for insert our new shell code. Let's copy and paste our new shell code. We paste our new shell code. Now let's adjust a variable value of variable junk and the value of variable IP. Let's adjust the value. The junk value offset is 35 down to 56. And let's adjust value of variable IP. Again, the variable junk means that will fill of character A, that means 41. 41 means X41 means character A, will fill with character A, till offset of IP, offset 35 down to 56 is an offset of IP, will fill with character A till offset of IP. In EIP, will overwrite if jump ISP. In EIP, will overwrite if address of make jump ISP for make a jump from EIP to ISP. In ISP, will fill with some loops, no operations. And in ISP, will put our shell code for make a reverse shell. In ISP, we'll put some loops of no operations in our shell code for make a reverse shell. Below, we have exploit equal junk concatenated with IP, concatenated with loops, concatenated with shell. Now let's compile our exploit code. Let's compile our exploit code per name of exploit code. Let's copy and paste our compiled exploit code in another VM. Now let's put our netcache for listening port. With netcache-lvvp port 5555 to listening port. Let's run our vulnerable software, and then let's load our compiled exploit code in our vulnerable software. And we have a shell. We have a shell. We have an IP of our other VM. We have a shell. You see it? In our slides, we have step by step of how you can write your own exploit code. We have step by step of how you can write your own exploit code. We have a complete exploit code. Complete exploit code. You see, thank you everyone. See you at the Discord channel for questions and answers. Thank you very much.